Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. In the series of videos for IBDP Maths, AAHL, and SL, today we are going to see past paper questions on functions topic. These questions are from standard level past papers, therefore this should be accessible to both HL and SL students. So both HL and SL students should be able to solve these questions. Under the topic for functions in the formula booklet, which you should be having in front of you now, we have these formulas: equations of straight line, gradient formula, axis of symmetry for quadratic functions, and quadratic formula and discriminant formula. And the last one, exponents and logarithmic functions, we have already dealt with in the previous video under exponents and logarithms. So you will not be using that exponential and logarithmic function formulas in this video. And you will also need some formulas from trigonometry, because some of the functions questions will be under trigonometry as well. So you might need to know all these formulas for this video, and you should be having a book and a pen and a graphing calculator for paper 2 questions. This video is split into two parts, paper 1 and paper 2 for standard level. And the questions that we are going to deal in this video are going to be coming up one after the other. So you can pause the video after each question, take down the questions and solve them. So this is the first question. You can take down, pause the video, take down the question and wait for the next question just coming up. This is the second question that we will be solving. Please take it down and pause the video. This is the third question. This is the fourth question. Pause the video after every question and take it down and solve them. And you can continue with the video for the solution as well as the marking scheme. This is the last question we'll be solving under paper 1. And for paper 2, standard level functions topic, we have this question and this one and this one. So 3 questions under paper 2. And we are going to go into paper 1 questions one by one now. Solve all the questions that you have taken down just now and then look for the solution and the marking scheme from this point onwards. So the first question, f of x is equal to p plus 9 over x minus q. Be careful about 9 and q there. 9 in the numerator, x minus q in the denominator. So this is the function given, and it's given that x is equal to 3 is a vertical asymptote for the graph f. And what is vertical asymptote? Is when the denominator is equal to 0, which means x minus q is equal to 0, which gives you x is equal to q as the vertical asymptote. It's given that x is equal to 3 is the vertical asymptote, and you are supposed to find the value for q in question A, which means q is equal to 3, comparing x is equal to 3 and x is equal to q. So we have q is equal to 3 for the first question. I hope you got this answer easily. The next is, the graph has y-intercept at 0, 4, which means f of 0 is equal to 4. If you substitute 0 in the place of x for f of x, your answer should be equal to 4. So these are the information that we have for question B. F of 0 is 4 and we already solved for q to be equal to 3. So we have this information. We have to find the value of p. So substitute this information in the function p plus 9 over 0 minus 3 because x is equal to 0. 0 minus 3 because q is equal to 3, and which is also going to be equal to 4 according to f of 0 equal to 4. Now simplifying this further, we will get that p is equal to 7. So you can do this easily as well. We found the value for p for question B. Next is, write down the equation of the horizontal asymptote of the graph. Horizontal asymptote means x tending to plus or minus infinity. Looking at the equation, substituting the values that we found for p and q in the function, we get f of x to be equal to 7 plus 9 over x minus 3. And as x tends to infinity, we can see that 9 over x minus 3 part tends to 9 over infinity. Anything over infinity, we know that it's going to be 0. So we have y tending to 7 plus this part becomes 0. So y tends to 7 plus 0 as x tends to infinity, which means y is equal to 7 is the horizontal asymptote. So we have the equation of the horizontal asymptote. Remember, horizontal asymptotes or vertical asymptotes should be given as an equation. Horizontal asymptotes will be of the form y equal to k. Vertical asymptotes will be of the form x is equal to k. So you have to give the equation for asymptotes as an equation, not just the number. Be careful about this. y is equal to 7 is the horizontal asymptote for this question, and it carries only 1 mark. Let's go for the marking scheme from the beginning of this question. For the first question, you have 1 mark, A1, just for giving the answer for Q is equal to 3. Next is method mark for substituting the value for 0 and Q and equal to 4, everything, method 1 mark. And answer 1 mark for correctly writing the equation with P. And finding the value for P as 7 gives you 1 A1 mark. And for the question C, we have just 1 mark for the equation y equal to 7. If you don't write it in equation form, you will not get this mark. So y is equal to 7 is the full answer for that A1 mark. I hope this is clear. Let's go for the next question. Going to the next question, we have a quadratic function given in the question. It's also given that the vertex is 3, -1. So the moment you see vertex here, you should remember that vertex is h, k, and the form for vertex is a times x minus h the whole square plus k. In this case, h, k is given to be 3, -1. So you should remember all these things the moment you see the vertex is given in the question. Now going back to the question, it's given that f of x is in the form of x minus h the whole square plus k, which means a in vertex form is equal to 1. The coefficient of x square is equal to 1 in the function given above. Therefore, we have to find the value of h and k, which is going to be very simple. H is equal to 3 and k is equal to -1. And going to the next part, x-intercepts are given 2 and 4. So the moment you see the x-intercept, you should understand that you can write the function as a product of factors using these roots. X minus 2 and x minus 4 will be the factors for the function. Going back to the question, we can say that another form of f of x is x minus a times x minus b. When you compare this with what you just thought, you can say that a is equal to 2 and b is equal to 4. It could be a equal to 4 and b equal to 2, but one of them is 4 and the other one is 2. Now the question is actually asking you to find the value of a and b, which you have already found easily. Now going for y-intercept for this function, y-intercept is always when x is equal to 0. Substitute x is equal to 0 in the factor form, 0 minus 2 times 0 minus 4, which will give you 8. Therefore, the y-intercept is 8. You can give the answer as y equal to 8 or y-intercept is equal to 8 or 0, 8 as a coordinate. Any of these forms are acceptable. Now going for the marking scheme, A1 and A1 for each of the values for h and k. Again, A1 and A1 mark for a and b. So just A marks for all these 4 values. But for C, we have a method mark for substituting x is equal to 0 in the equation to get the y-intercept, and also the correct y-intercept as 8. So these are the marks for this question. I hope you got all these marks because this is one of the very simple questions in the papers. Going to the next question, consider the function f of x is equal to 1 minus k times x square. The moment you see that, you should understand that we are in quadratic function topic here. And we need to find the value of k for which f of x has 2 equal real roots. In this case, since you see the word roots, you should not be going for the quadratic formula to find the roots. In this case, we are going to be using the discriminant equal to 0 condition because we need to have 2 equal roots, which comes under the nature of roots for quadratic. So you should know that we are going to use discriminant here, b square minus 4ac. For 2 equal roots, it should be equal to 0. So this is what you need to understand at this point. And now we will continue with substituting the values for a, b and c from the function into the discriminant b square minus 4ac here. A is 1 minus k, b is 1 and c is k. Substituting them in b square minus 4ac equal to 0, we will get this as our equation now. Don't forget that b is 1 and 1 square is there. 1 minus 4 times 1 minus k times k. Simplifying this, you will get a quadratic in k, which is 4k square minus 4k plus 1. And you need to solve this quadratic in any way you want, but I will be able to recognize this as a perfect square, 2k minus 1 whole square. You can also use quadratic formula to find the k value, and the k value should be equal to half. And go back to the question, you are going to find a value for k, so which means getting half for as one value for k is okay for here. So you are confident that your answer is going to be correct. Let's go back and check the marking scheme. Marking scheme gives you A1 mark for using the discriminant and A1 mark for correctly using the discriminant, substituting the correct values of A and B and C, and then getting this equation in quadratic for K. And method 1 mark for equating the discriminant to equal to 0 at any point in the steps. And the next mark is for solving the equation in K and finding the value of K is A1 mark. So there are 6 marks, which is quite easy to get. Let's proceed further to the next question. This is your next question. For question A, you have to prove that LHS is equal to RHS. LHS is left hand side, RHS is right hand side. So for HL students, we will start from left hand side and prove that that is going to be simplified to the value in the right hand side. But for higher level students, since you know how to divide two polynomials, you can simply divide the quadratic by the linear and you will be able to get the expression in the left hand side. So you can start as HL students, you can start it from RHS and prove that that is equal to LHS. But here I am going to show how to start from LHS and prove that it is equal to RHS. So starting from LHS, this is what you have in the LHS, left hand side. You have to simplify this. In order to simplify this, we have to make the common denominator, which is x minus 1. And the numerator will be 2x times x minus 1 minus 3 times x minus 1 minus 6. So this is going to be your numerator and the denominator when you simplify the left hand side. Now you have to expand the numerator and keep the denominator as x minus 1. Expanding the numerator and simplifying this, you will get this as 2x square minus 5x minus 3 divided by x minus 1, which is nothing but the right hand side given in the question. So you have reached the right hand side starting from left hand side. So this is all for show that question for question A. Next we are going to question B. You have in question B 2 sine 2 theta minus 3 minus 6 over sine 2 theta minus 1 is equal to 0, and you have to solve this equation. It's a hence or otherwise question, so there should be some connection to this with question A. Looking back at question A, you can see that you simply have to substitute x as sine 2 theta. Then you are going to get question A in question B form. Now simplification of question A, the left hand side becomes this on the right hand side. Therefore we can also equate this to be equal to 0. On simplification, this quadratic equal to 0. And you have the factorization of the quadratic as 2x plus 1 times x minus 3 equal to 0. You can do all these things with sine 2 theta in the place of x if you are comfortable. But I would prefer change this to x. It's easy to solve with x than with sine 2 theta. So once you get this, you can find the values of x to be equal to -½ and 3. Now what we have after changing x to sine 2 theta is sine 2 theta is equal to -½ and sine 2 theta is equal to 3. So these are the two equations we have in terms of sine 2 theta from question A, applying the question A into question B. But you can see that the second equation has a value greater than 1, which means there is no solution for sine 2 theta equal to 3. Now we have to solve for sine 2 theta equal to -½ But before we solve that, let's see the domain. Domain for theta is for 0 to pi, but we have 2 theta in the angle. Therefore the domain for 2 theta will be 0 to 2 pi. So we have to find the value of theta for which 2 theta is between 0 and 2 pi. For -½ sine inverse of half is pi over 6. And we are going to have the values, since it is negative, it's going to be in third and fourth quadrant for sine theta as a negative value. Now we will have 2 theta is equal to pi plus pi over 6 for the third quadrant, which gives you theta as 7 pi over 12. And the next value in the fourth quadrant is 2 pi minus pi over 6, which gives you theta to be equal to 11 pi over 12. So these are the two values for theta for solving sine 2 theta equal to -½ As I told in the beginning, you could have noticed that we are using trigonometry under the functions topic here. So it's a combination of both functions and trigonometry in this question. Now let's go for the marking scheme. Method 1 mark for starting with LHS or RHS, either way, starting from one side and proving it to be equal to the next side. Don't put both the sides in the same line. You have to start from one side and prove it that to be equal to the other side. So do not write LHS equal to RHS and keep solving 0 equal to 0 form. That's not the way to solve. Method 1 mark is only for knowing that you have to start with one side, prove that it is equal to the other side. Answer 1 mark for simplifying the whichever side you have taken. So in this case, you are going to open the brackets for 2x times x minus 1, 3 times x minus 1, and writing the numerator in the expanded form. You can notice that this question has only 2 marks, and this is AG marks, which is answer given. So you will not get marks for writing the right hand side there and making it equal to RHS without writing the expansion of the numerator in the previous step. So M1 and A1 and AG is not mark given to you. It says that answer is given, so there is no mark for writing that step here. Going further for question B, method 1 mark for identifying this as equal to a quadratic, and method 1 mark for writing the correct quadratic, and answer 1 mark for writing the equation with sine 2 theta equal to negative half, and answer 1 mark for finding the third and quadrant 2 theta form, and answer 1 mark for finding final answer for theta. So we have done with this question. This is slightly complicated than the previous questions, but you have to be very careful in many places where you have to change the domain of theta to 2 theta, and you have to use the previous section A for finding the quadratic and solving the quadratic here. And you have to know that sine 2 theta equal to 3 doesn't have a solution. So this is paper 1 question. Therefore, you cannot use your calculator as well. Let's move further to the next question. F of x is equal to 2x minus 1 over x plus 3. Rational function. Now we have to give the vertical asymptote of the graph. You know that for vertical asymptote, denominator is equal to 0. So for that, we have to make x plus 3 in the denominator to be equal to 0, which eventually gives you x is equal to minus 3. Remember, vertical asymptote should be an equation. Actually, if you go back to the question, you can read the question. A, write down the equation of the vertical asymptote. So the equation is x is equal to k. In this case, the equation is x is equal to minus 3. Do not write just minus 3. You will not get any marks for that. Going for B question, which is inverse function for the given function, we have to first of all write y is equal to 2x minus 1 over x plus 3, and then interchange x and y. Write it as x is equal to 2y minus 1 over y plus 3, and then solve for y here. I'm going to give it quickly here. You can solve it by yourself. Now you get y is equal to negative 1 minus 3x over x minus 2, but that will not give you final mark. The final mark is given only when you change y to f inverse of x. So your final answer should look like f inverse of x is equal to minus 1 minus 3x over x minus 2. It could also be 1 plus 3x over 2 minus x. That's fine. But the y part should be f inverse of x in this case. The final answer should have f inverse of x in the answer there. And going for question C, horizontal asymptote again, but you already know the formula for horizontal asymptote for rational functions. If the rational function is of the form ax plus b over cx plus d, the horizontal asymptote is y is equal to a over c, the coefficient of x in the numerator divided by the coefficient of x in the denominator. You should have learned this in this chapter already. We are just going to use this formula here. And we have a as minus 3 and b is 1 because it has a coefficient of 1 in the denominator. So y is equal to negative 3 over 1, which gives you negative 3. And don't leave the answer here. The final answer should be as an equation y is equal to negative 3, which is the horizontal asymptote. Going for the answer scheme, 1 mark for just writing the equation of the vertical asymptote in the form x is equal to k. And method 1 mark for interchanging x and y for question B for finding the inverse function and actually finding the y value in terms of x, and writing the final answer as f inverse of x is equal to the given answer. So this is the marking scheme for finding inverse functions in general always. Interchanging x and y will always have a method mark, and the final answer will be only for f inverse of x is equal to the answer. And in between the steps could have any number of marks. In this case, since it's very simple, you have only one A1 mark in this question. Going for question C, marking scheme. You have 2 marks for that question. Method mark for applying A over C formula or any other method. For example, you could have applied extending to infinity method as well, limiting method for highest level students. That would also carry this method mark. But in this case, this method mark is for any method that you are using to find horizontal asymptote. And the final answer mark is only when you give the final answer as an equation y equal to k. If you write negative 3, you are not going to get that A1 mark. Y equal to negative 3 is the final answer for horizontal asymptote. Let's go further to the next question. This is a function given. We do not know what type of function it is, but a function is given with x-intercept as 5, 0 and y-intercept as 0, 8. Now we need to find the y-intercept of f of x plus 3 and f of 4x. Transformation of functions here. And we need to know that f of x plus 3 is a vertical shift by 3 units upwards. So if you know this, you can easily answer the question A1. We have to find the y-intercept for number 1, which is f of x plus 3. For y-intercept of f of x is 8. Therefore 8 plus 3 will give you the y-intercept of f of x plus 3, which is 0, 11. So this is the answer for A1. F of ax is a horizontal stretch and it doesn't change the y-intercept. You can either use this concept and say that the y-intercept is the same as f of x, which is going to be 8, but we can also substitute x is equal to 0 in f of 4x, which gives you f of 0. But f of 0 is 8 because we already have that 8 is the y-intercept of f of x. Therefore f of 0 equal to 8. Therefore f of 4 times 0 is also equal to 8. Therefore at x is equal to 0, we have f of 4x to be equal to 8. Therefore y-intercept is equal to 8. For second question of A part, you can also say that since it's an horizontal stretch, y-intercept is invariable. Therefore you can have the same y variable as f of x for f of 4x. Now going for B question, you need to find the x-intercept of f of 2x. Therefore you have to equate f of 2x to equal to 0. Looking into the original function, we have x-intercept of the original function is 5. Therefore we have f of 5 is equal to 0. Therefore we can equate them both. 2x is equal to 5. Therefore x is equal to 5 over 2. 5 over 2 comma 0 is the coordinate of the x-intercept. You can also just leave it as x is equal to 5 over 2 because in the question you are not asked to give the answer as coordinate form. You are just asked to find the x-intercept. So it's okay if you give x is equal to 5 over 2. You will get the marks there. But if the question was asking for coordinate of the x-intercept, your final answer should be 5 over 2 comma 0. Take care of how the question is being worded. Accordingly, you have to give the answer. In this case, x is equal to 5 by 2 is okay. Going for the next question, describe the transformation f of x plus 1. It's very easy to say. It's a horizontal translation by 1 unit to the left. Horizontal translation or shift and left and 1 unit. These are the words that is supposed to be seen in your description. And we'll go for the marking scheme from the beginning. A1 mark for finding the value of y-intercept for f of x plus 3. And method 1 mark for any method that you are going to use to find that the y-intercept of f of 4x is equal to 8. And A1 mark for the answer 8. And for question B, you have 2 marks directly for getting the value of x is equal to 5 over 2. So you either get 2 marks or you don't get any mark for this question. So there is no method mark. There might be method 1 or answer 1 mark for this question. So it's better you show the working as well as the answer. In this case, unfortunately, we have 2 marks directly for the value of x. But as I said, sometimes you might have method 1 mark and answer 1 mark for these type of questions. Going to question C, you have answer 1 mark for having all these 4 information: horizontal, the word translation or shift, the word left, the word 1 unit. All these 4 things together gives you 2 marks. You have to have all these 4 words in order to get both the marks A1 and A1 for question C. Let's move further to paper 2 questions. I hope you got all the paper 1 questions correct. You can now keep your solutions for paper 2 questions ready in front of you and check the solution and the marking scheme now. First question is this. You have f of x and g of x. This is a composition of functions. The first question is very simple. I'm going to go a little faster on giving you the solution for this. Putting g of x inside f of x. G of x is x square minus 2. So f of x square minus 2 is x square minus 2 the whole square minus 1. Write them clearly from f of x and g of x. And the final answer is a show that answer. Therefore, it will not have any marks. You are okay when you get the answer as given in the question, x power 4 minus 4x square plus 3. You got it right here. Going for the next question on the following grid. This grid is already given in the question. This is paper 2 question. So pick up your calculator. See that you have your window setting according to the grid given here. Looking at the grid, we can say that the x-axis is from negative 0.25 to 2.5. And the y-axis has the values from negative 2 all the way to positive 10. So make your window setting in such a way that you get this window in your calculator as well. And the question is going to be sketch the graph for f of g of x between the values 0 and 2.25. Be careful when the domain is given. The graph should be given only in this domain. It should not go beyond this domain. So you have to give the graph within this domain only. For that, you need to find the extremes here. So f of g of 0 is 3. F of g of 2.25 is 8.38. So these two endpoints should be given on the graph. The graph should look like this. The information that you need to show on the graph are the endpoints, the x-intercepts and the minimum point. These are the coordinates that you need to specify on your graph that you draw on the grid here. And if you have the window setting corresponding to what is given in the question paper, you will get the clear picture of the graph and you will be able to draw this easily. Be careful that you are not supposed to give any part of the graph before 0 and after 2.25. It should stop at 0 and it should stop at 2.25. Only then you will get the marks for this question. Next C question is f of g of x is equal to k, which means we are going to look for the solutions for the line y equal to k meeting with f of g of x. So we will draw different y equal to k lines and see where they meet for f of g of x, and see where exactly you get two solutions, which k values will give you exactly two solutions when they meet the f of g of x function. So let's go further to see how it works. So this is the line y equal to k. At the moment it is y equal to negative 1.8, negative 1.6, negative 1.4, negative 1.2, and if you see that at negative 1 you have one value, after that you have two values on the graph. So it is meeting at 2 points after negative 1, y equal to k, and the function meets at 2 points here. Until this point you have two solutions. For y equal to 3 also you have two solutions, but after y equal to 3 you can see that the intersection is only 1 point. Therefore from y equal to negative 1 all the way to 3 you have 2 points of intersection between the line y equal to k and the function given. So the answer for C is negative 1 less than k less than or equal to 3. You should notice that at the point when y equal to negative 1 we had only one solution, but when it was equal to 3 we had two solutions. And you need to be careful about the inequalities here. There is no equal to sign for negative 1, but k is equal to 3 is included. So this is the answer for question C. Now going for marking scheme, method 1 mark for correctly entering the g of x into f of x and writing the expansion of the f of x square minus 2 correctly, and this is answer given, therefore there is no mark for writing the last step. Now as I said, shape has A1 mark for question B. If you don't give the function between 0 and 2.25, this mark will not be given for this question. This A1 mark is for both the shape as well as the correct domain. Next is for both the endpoints, and 1 mark for the minimum point. There might be a mark for x-intercept, but it is not given for this question in the marking scheme. But it is always advisable to give all the important points on the graph, the x coordinates, y coordinates, maximum or minimum, and the endpoints if it is a restricted domain. Method 1 mark and answer 2 marks. So method 1 mark for any method you want to show, you can simply draw lines at y equal to negative 1 and y equal to 3 and show that at y equal to negative 1 it is one solution, and after that you have two solutions. So between these two lines you have two solutions for f of g of x is equal to k, and therefore it is negative 1 less than k less than or equal to 3 altogether gives you A2 marks. Whenever you have A2 marks, it's A2 or A0, so be careful to write the inequalities clearly. Proceeding further to the next question, it's an exponential question, e power minus x square minus 0.5 for again restricted domain negative 2 to 2. We have to find the values of f of x is equal to 0, which is e power minus x square minus 0.5 is equal to 0. You can either use GDC directly and draw the graph and find the x-intercepts, or you can simplify this to this form and use the calculator simply to find the value of plus or minus square root of minus ln of 0.5, which is going to be plus or minus 0.833. So in this way you are not going for graphical methods, but in the next question you are supposed to be drawing the graph of f of x anyways, so you could have drawn this before and then found it directly from the GDC as well. So either way is okay, but the diagram should be between negative 2 and positive 2. Again, it should not go beyond negative 2 and positive 2 on both the sides. You should be giving the x-intercepts and y-intercepts. In this case, y-intercept and maximum point are the same. Going for the marking scheme for question A, A1 and A1 mark for plus 0.833 and minus 0.833. Three significant figures. Be careful about that. If you are not giving the answer in correct to three significant figures, you might not get both these marks. So all the calculator questions, you have to be very careful to give the answers in three significant figures. Even on the graph, I have given this in two significant figures. Be careful that you set your calculator to three significant figures and give the answers in three significant figures. Going for the marking scheme for sketching the graph question, we have A1 mark for the correct shape and A1 mark for both the x-intercepts. and A1 mark for the correct endpoints, minus 2 comma whatever it is, 2 comma whatever it is. If you have this stopped at this minus 2 and 2, you will get A1 mark for this. If you don't, if you extend this beyond these two ranges, then you will not get that A1 mark. And therefore be careful when there is a domain given in the question. Let's proceed further to the last question here. F of x is 6x minus 1 over 2x plus 3, and this is also another rational function. We have to find the y-intercept, which is easy to find. Put x is equal to 0 and y-intercept is 0 comma negative 1 over 3. That's easy. Find the equation of the vertical asymptote. Be careful. And equation vertical asymptote is when denominator equal to 0. If you put the denominator 2x plus 3 equal to 0, you will get x is equal to negative 3 over 2. Don't simply write negative 3 over 2. It is x is equal to negative 3 over 2 is the equation of the vertical asymptote. Next question is horizontal asymptote. It's the A over C part, which we have already seen in the previous questions. A is 6, C is 2 from the question above. So 6 over 2 is 3. So y is equal to 3 is the equation of the horizontal asymptote. You can stop here for A, and for B, limit of x tending to infinity of the given function. So we are supposed to find x tending to infinity of this function, which means we are basically finding the horizontal asymptote for this function, which we have already found it to be equal to 3. Therefore, the limiting condition is equal to actually 3. So this is what you need to do for this question. There is no need to actually find the limit. You have to identify that limit extending to infinity of a function is horizontal asymptote, which was already given in question A. And that is why you are having the question B as hence or otherwise, which means you are using the part of A to answer question B. The helpful part from question A is horizontal asymptote part. So just simply use that part to give the answer as equal to 3. The limit is equal to 3. That's it. Let's go for the marking scheme of this question. Applying x is equal to 0 to find the y-intercept is method 1 mark. Actually finding the y-intercept is A1 mark. And A1 mark for giving the equation of the vertical asymptote. And you have a method mark for identifying y equal to A over C is the horizontal asymptote, and the actual answer mark for y equal to 3 equation again. And for question B, you have method mark for identifying that the limit extending to infinity is nothing but horizontal asymptote, and the final mark as equal to 3 for A1. So this is the marking scheme for this question. I hope you enjoyed this video and it was very helpful for you to understand the past paper questions under functions for standard level. Until we meet next with higher level functions questions. Thanks for watching. Happy learning from Ganitika.com. If you like my videos, please subscribe, like and share my videos with your friends and families. Specifically for this video, I would like you to subscribe because when I upload the HL questions for functions, you will be getting the notification. Therefore, subscribe now for getting the notification for my next upload on HL functions. Thank you for watching.